Hello, ladies and gentlemen, welcome back. This is video number 2. Here we're again continuing with confidence intervals of means, and we have a very specific type of situation that we're going to look at here. This is called a paired T procedure. Okay, to compare the responses to the two treatments in a matched pairs design, or a before and after measurement on the same subjects. Okay, on the same subjects. Apply one sample T procedures to the observed differences. All right, so let's go ahead and look at an example of this. Here we go. So, confidence interval for a mean difference. Something suspicious in the Belfi. All right, so okay, we have some bats, right? Okay, for some reason bats creep me out, ladies and gentlemen. All right, due to the stigma attached to animals that work with the night shift, live in the netherworld, and star in horror films, and perhaps due to problems associated with the study of nocturnal organisms, bats have received less than their share of biological attention. So, just how much do creatures eat in 5 minutes of swooping? Okay, so ladies and gentlemen, we're using the same bats here. Okay, you'll notice that we've got 19 bats. And they weighed the bats like before they went out to eat. And then what did they weigh after they fed? And you will notice we've got a column here of the differences. Okay, so we're taking and finding the difference, well, actually the other way around. We're taking how much they weigh after they eat minus, so we're taking their post weight minus their original weight. And then we're getting the differences. Okay, so that is a T procedure, a matched pairs T procedure, because we're using the same subjects and we're finding the difference. All right, so when we would do this problem, ladies and gentlemen, we would only use the data of the differences in their weight. All right. Step 1 is the statistic. That's the mean difference. So we would only type in the 1.22.3. That's what we would type in list 1. We don't type in these other numbers in the list. Okay, we're going to do a 95% confidence level and the sampling distribution. We're going to check it. All right, so here is the assess the credibility of the sample distribution. You will notice, ladies and gentlemen, okay, this professor got a little crazy here. This professor did a normal probability plot, and the professor did a box and whisker plot, and actually did a histogram. Okay, the histogram doesn't look very good though, does it? So I would just again stick with the box and whisker plot. Okay, and then you would need to talk about it. Okay, so oops, wrong way. I don't think that the professor says much here. So we would have to say that based on this box and whisker plot that it is approximately normal. Okay, there's nothing wrong with it. All right, so we're going to use the T procedure just like we did in the last video. Our degrees of freedom is going to be 18. So again, here's our X bar. Here's our T star from table B, standard deviation divided by the square root of 19, and there's our interval. Interpret. I am 95% confident that the population mean weight gain of, okay, not even going to attempt to say that, over 5-minute feeding period is 1.45 and 1.8 grams. So that's how much we expect those bats to gain in weight over a 5-minute feeding period. All right, so let's look at another example here, ladies and gentlemen. Okay, go into a little bit more detail with this one. You can print this one off. This one is above the videos if you want to print it. Differences of electric potential occur naturally from point to point on a body's skin. In the natural electric field strength best for helping wounds to heal? If so, changing the field will slow healing. The researchers' subjects are anesthetized newts. If you don't know what they are, Google it. All right, make a razor cut on both limbs. Sounds cruel, doesn't it? Let one heal naturally, that's your control. Use the electrode to change the electric field in the other to half its normal value. After 2 hours, measure the healing rate. The table gives the healing rates in micrometers per hour for 14 newts. All right, so you can see our experimental limb and then our control limb. All right, so what we're going to do is we're going to subtract between the experimental limb and the control limb. So we're going to actually subtract in this way. So the difference here is -1. Here it's 10. The difference here is 3. -3. -31. 4, 12. And let's keep going. We've got -3. -7. -10, -22, -4, -1, and -3. All right, so those are the differences. Let's continue. All right, so it's our job to construct and interpret a 90% confidence interval for the mean amount by which changing the field changes the rate of healing. Follow the inference toolbox. All right, so the parameter. The population of interest is the mean difference in healing rates between the control limb and the experimental limb of newts. That's what we are interested in doing. And if you want to throw in the 90% confidence interval in the, with that, then you could. Okay, again, I'm going to go fast, so you may need to do a lot of pausing. Conditions. Simple random sample. It is not stated, so we're going to proceed with caution. And then at the end, we're going to say something about that, okay? So it's not stated, we're going to proceed with caution. Normality. Since the sample size is small and the distribution of differences is skewed to the left with an outlier, the normal distribution is not appropriate. Okay, so this is what we actually ended up with. If you did the box and whisker, I'm not going to put any numbers on this, but you need to put numbers on it if this was an AP test. Okay, this is what it looks like if you actually drew it on the calculator. It would look something like this. And it's got an outlier. That's a big, that's a big red X, folks. Warning, warning, warning. Okay, since the sample size is small and the distribution of differences is skewed to the left with an outlier, the normal distribution is not appropriate. Okay, but we're going to keep going here because we're going to talk about that at the end. Okay, or you could look at the normal probability plot, folks. So that's what the normal probability plot would look like. So the normal probability plot is not very linear, slightly curved on the left side, which indicates the data is not normal, therefore the normal distribution is not appropriate. Okay, so there's the normal probability plot. Now, the independence piece, we must assume that there are at least 10 times the sample size or 140 newts in the population. So there were two things violated here. Okay, the simple random sample was violated because it did not say that it was a simple random sample, and the normality was violated. And we're going to talk about that when we come up with our conclusion. All right, so you would do the same thing on the AP test if you ran across one like this. So we found the mean, ladies and gentlemen. We found the mean to be -5.71. The degrees of freedom is 13. Then we went to the table, found our T star, and there's our standard deviation. We plug that into our formula, ladies and gentlemen, and we come up with negative 10.708 to negative 0.712. Oh, and our sample size is 14. Interpretation. Okay, now I'm a little bit more detailed here than I was in the past. Using degrees of freedom of 13 and a T star of 1.771, we are 90% confident that the mean difference in healing rate is between negative 10.708 and negative 0.712 micrometers per hour. However, after all of that, ladies and gentlemen, based on the conditions, simple random sample and normality, we cannot rely on these results. The confidence interval, I'm going to change this, may not be valid. Okay, it may not be valid. So that means the results are not reliable. That's why those conditions are so important, because we want to be able to come up with a conclusion, which is going to be the whole point of inference over the next 2-3 months before the AP test with what we're learning. All right, now continuing with a few things, I want to talk about robust. An inference procedure is called robust if the probability calculations involved in that procedure remain fairly accurate when a condition for use of the procedure is violated. Okay, so let's say that last example I did, there were conditions that were violated. Okay. There are situations where we could say it's robust. That means it's still fairly accurate, even though some conditions were violated. For confidence intervals, this means that the stated confidence level is still fairly accurate. Now, that last example, I would not call that robust. Okay? I would not call that robust. Using T procedures. Except in the case of small samples, the assumption that the data are an SRS from the population of interest is more important than the assumption that the population distribution is normal. Ooh, okay, read that again. Okay, pause and read that again. Sample size less than 15. Why? You said 30 in there. Okay, situation changed. Sample size less than 15. Use T procedures if the data are close to normal. If the data are clearly non-normal or if outliers are present, do not use the T procedures. We saw that in that one. We had an outlier. But we still carried it out, and then at the end we said, nope, nix it. We can't do it. Sample size at least 15. The T procedure can be used except in the presence of outliers or strong skewness. Okay, now think between the second and the third bullet. Okay, pause and read those two again and think about the difference. Large samples. The T procedure can be used even for clearly skewed distributions when the sample is large and is greater than 30. All right. And I'm going to show you some calculator stuff in the next video. You are going to want to watch that. Now, before I do that though, I just want to caution you, ladies and gentlemen, you still have to, when you do the calculations, you still have to show all of this. The calculator, it's gonna give you you're gonna plug in numbers and it's gonna give you the answer. But all of this needs to be shown. Now this step, you could probably skip that step, okay, and go from here to here, and that's what the calculator is going to show us, all right? So make sure you watch that next video. All right, I'll see you soon, ladies and gentlemen.